مساء الخير. بس I'm sure it's worth it صراحة، لأن ضيفتنا الجاية هي أول سعودية، أكيد عارفينها. يعني إحنا من فترة كنا نشوف على السوشيال ميديا وعلى الانترناشونال ميديا، حتى على الإعلام العربي، تطلع لنا مشاعل وتتكلم عن تجربتها الخاصة، تتكلم عن طموحها وكيف حققت طموحها وشو اللي سوته غير العربيات اللي كانوا يحبون يدخلون مجال الفضاء. جلستنا القادمة حضورنا الكريم عن ريادة الأعمال في عصر الفضاء الجديد. فيها بتتكلم متحدثتنا مشاعل الشميمري، وهي أول سعودية متخصصة في الصواريخ الفضائية. بتوضح كيف تحولت قصتها إلى واقع، كيف صار فضولها واقع، كيف حققت حلمها، شو التحديات اللي تواجهها في صناعة الفضاء، التصميم، الاختبار، التمويل، وأيضاً العمليات. جمهورنا الكريم، السعودية مشاعل الشميمري.
السلام عليكم ورحمة الله وبركاته. أنا حخلي البرزنتيشن حقتي بالإنجليزي، عاد سامحوني. Okay, so to start, the whole point of this presentation is to give you an idea what it takes to have entrepreneurship in the age of new space. So to begin with, how did it all start in my life? I was inspired by the deserts of Ineza. My mom decided to take me to Ineza Desert. She took me at night, and when I went, as you know, the desert climate at night, it gets pretty chilly, it gets cold. So I was there, the temperature was dropping, it was nighttime, I look up in the sky, and I see a high density of stars that was so astonishing. And from that moment, when I saw these stars, I said, you know what? Why are the stars up there? I asked my mom, I asked my sister, I said, hey guys, why are these stars up there? Why do these stars flicker more than these? Why is this flickering red and this one is flickering blue? And so I kept asking a lot of questions. At age 6, I really needed answers. So I kept asking and asking, I wouldn't stop. And then when we were driving in the car at night, I would ask my mom, Mom, why is the moon following us? And my mom's like, oh, it's not following us, it's just up in space. And I'm like, no, I need answers. So one day, my sister Sarah decides, I'm so sick of you and your questions. Because Sarah, my sister, is like a year and 3 months older than I am. And she said, listen, I got the answer. I said, okay. I'm like sitting there, super excited that she's going to give me all the answers I want. She got a piece of paper, put some glue on it, and then sprinkled some glitter. And then she took the piece of paper, and she said, you see, it's flickering like the stars, right? It looks like the stars. I said, yes. She's like, that's it. God did this. We're done. Stop asking questions. And so I thought that was brilliant. Like, I was like, wow, this is creative, but not good enough for me. So then I decided from that moment at age 6 that space is my calling. I must go to space. In order to do so, I need to make rockets. And in order to make rockets, you have to be an aerospace engineer. So I was like, that's it. I'm going to be an engineer, an aerospace engineer with focus on rockets. From that day, my journey began. So I was more interested in science and engineering and that sort of thing. So I blew up the house a couple of times. I blew out the fuses in the house multiple times. So my mom used to really worry when she leaves the house that I will blow up something in the house every time. So because I always ran experiments at home. In order to get an aerospace degree, obviously you have to go to college. And in college, I had 2 majors for my bachelor's, aerospace engineering and applied mathematics. Because aerospace requires so much math, I figured, hey, get another degree. And then I did my master's in aerospace engineering as well. The master's was actually funded by NASA Marshall Space Flight Center. This is the department within NASA that is in charge of design of new vehicles. My job with this research was to design a nuclear thermal rocket for Mars missions. So these are the types of rockets that we would use to go to Mars, specifically to take humans to Mars. So the research was to design, analyze, and create a new design for a nuclear rocket that will be utilized for space applications. Following that, I worked for Raytheon. I'm sure a lot of you are familiar with Raytheon. It's one of the biggest defense contractors in the US. I worked there for a few years, and while there, worked on 22 different rockets. And then, before I get into the entrepreneurship in aerospace, I would like to discuss a little bit of history in space. So to begin with, I'm going to ask you guys a question. Are you familiar with why the US decided to go to the moon? Go ahead. Yeah, correct. So the Cold War was the spark. What happened was the Russians, they went into space first. They sent the first satellite, Sputnik, in space. Then they sent the first human in space, Yuri Gagarin. And so they achieved so many milestones. And the US is like, no way, we're not having this anymore. Not only do we want to go to space, we're going to go to the moon. That's it. So that concept, it's very important to talk about the market, because when you talk about the history, that concept of I will go there at whatever cost, which means I'm willing to put as much money required in order to get to the moon. So the mentality was, I will achieve no matter what the cost is. Okay? That was the age of following the Cold War. So that kind of sparked, the Mercury program and so forth, and eventually they got to the Apollo program. Following that, you didn't have much competition in the rocket business in getting into space. You had very little players. You had Boeing, you had some other small, like, not small, but other companies, but it's a very small number, so there's not high competition. By not having high competition, guess what? Your prices are going to be very high. And if you are constantly trying to seek and put money to achieve at whatever cost, then you are going to basically have stagnant prices that are not going to go down. Quick question. How many of you think they know how much the Apollo program cost? Just the Apollo. I'm not talking about Gemini, Mercury. Give or take. How many billions of dollars? 13 billion? No, 24.5 billion. So it's a lot of money that was spent on the Apollo program. So that kind of gives you an idea, like, oh my God, going to space is pretty expensive. Now, fast forward a little bit after that, well, a lot actually. So in the 2000s, the mentality started to shift. What was the spark? The spark was basically the space shuttle program ending. You guys are familiar with the space shuttle, right? So the space shuttle, as you know, after the Columbia accident in 2003, it became an issue like, oh, the space shuttle is getting older, it's 30 years old, we need to replace it, it costs too much to maintain, it costs too much to operate, so therefore we have to shut down this program. We had this accident with 2003 with the Columbia, so therefore we need to start wrapping it up. Originally, the idea was to stop the shuttle program in 2009. Then they pushed it back and pushed it back. Eventually, they stopped the shuttle program, which is the only means that the US has to go to send humans to space. They stopped it in 2011. That sparked, initially when the talk started in 2003 about like the space shuttle program being discontinued and so forth, it sparked that interest in the entrepreneurship side. They're like, oh, why is it so hard to go to space? Why does it cost so much money? We need to change that. So then you started to get players like SpaceX, Virgin Galactic, and so many other companies that were trying to push the envelope when it comes to cost, to going to space, and when it comes to developing new technology that is an improvement to old technologies that we were using. So, and then you have companies like myself, Michelle Aerospace, that wanted to get into that entrepreneurship in space and to reduce the cost. So the difference between old space and new space, as I mentioned, old space, I will achieve at whatever cost, whereas new space, I will achieve with the eye on cost. So I want to push the prices down. I want to also achieve certain exploration in space. Not only do I want to go to Mars, not only do I want to go back to the moon, not only do I want to go to mine asteroids, so basically go on an asteroid, mine it, and bring back samples. I also want to go to the moon and bring back samples to Earth. I want to colonize Mars. So these ideas are coming up with very high ambition. In addition, you also have space tourism. People are becoming more exposed. Like your average person is becoming more exposed to space, and they want to go to space. So you have space tourism as well as some of the ideas. So you have these grand ideas that are formulating within the aerospace arena. With that in mind, so following my work at Raytheon, at the time, when I left Raytheon, a lot of the companies, you're familiar with the recession of 2008. Obviously, it trickled down to the aerospace industry around 2010. At that time, a lot of the aerospace companies in the US were laying off people, not hiring. So I was faced with the idea of, shall I sit here and mope, or create my own opportunity. So at age 26, I was like, you know what? Let me analyze what's going on in the market, and I've always wanted to make rockets from scratch and go to space. Therefore, let me create my own opportunity. At age 26, I decided I'm going to start Mishal Aerospace, and our goal is to create rockets. But the market at the time, when I was introduced to my chief engineer, Rick Lohr, I was introduced to him, and we started to look at the market, and we recognized there's a serious gap in launching what's small satellites. Small satellites is a segment of the satellite market that is between 1 kilogram all the way up to 500 kilograms. That was our target market. Why? Because they were facing a severe problem launching as secondary or tertiary payloads, because all the rockets that exist are made for very heavy payloads. So they can take like 29,000 pounds, and if you're like a few hundred pounds or 1,000 pounds, you're not the primary. So therefore, you have to actually piggyback on a larger payload. So you don't have a say as to when you launch, how you launch, or where you launch to. So in having that problem, and as you know, technology is miniaturized. How often do you guys change your phones? Like today, you buy an Apple XR or whatever we're at right now. Tomorrow, like how long do you think before the new iPhone comes out? 6 months to 1 year, right? Because technology advances so fast. Imagine that for satellites. You make a satellite, the technology has miniaturized so much that now you are capable of having a very powerful satellite. Actually, I can hold in my hand, literally. And then I send it to space. You have CubeSats, you have microsats, you have all these small satellites, extremely powerful. So when you want to launch, what happens, you try to put your manifest on a rocket, and you find out that, oh, I have to wait 3 years. Well, 3 years, my satellite is already archaic because technology has advanced so much. So they were facing that problem. And my goal was to provide a solution and have a dedicated rocket my customer is just the small satellite market, up to 500 kilogram. So with that, I would like to show you a video, if you can play it, please.
My name is Mishal Ashramri.
Can you put the volume
My
up?
background is in aerospace engineering. I got my degree from Florida Institute of Technology, and my specialty is in rocket design. I've always known that I wanted to be an aerospace engineer since I was 6 years old, when I was gazing at the stars and wondering what they were. If I wanted to understand them, I need to go into space. And in order for me to go into space, I need to develop the rockets that take me there. The mission of Mishal Aerospace is to develop low-cost rockets for space access, including orbital and lunar missions. Our vision is to allow smaller satellites to have access to space and allow the general public to have a cost-effective means to go into space. The technology has been advanced and technology is becoming miniaturized, so there's a lot more satellites that are getting smaller and smaller, but yet have no way of accessing space. A lot of the rockets that exist today are targeted for larger satellites and larger payloads, so there's a huge gap in that market. And that's how we decided to try to cater to that market, because they're growing, and the main problem that they're having is they don't have a cost-effective way of access to space. We have 2 locations. The headquarters is in Miami, Florida, which is where we do the design simulation, and we have the Arizona office, which contains the integration, testing, and putting hardware together. So Mishal Aerospace is developing the following rocket line. It's called the M rocket. Our first rocket is the MSV, which is this one. It's a hybrid rocket booster, and it's intended for a microgravity environment, meaning it just goes into space and then comes back down. This MSV, which uses the hybrid rocket, is used as a booster in the MOV. So this is the MOV, which is the orbital vehicle. Its intention is to put a satellite into orbit. We have the last line here is the MLV, which is the lunar vehicle. A successor of this would be the MHLV, which is the heavy lifting vehicle. That rocket will be able to go to the moon and bring back samples to Earth. So in addition to our M rocket line, we also provide the launch service. We have our own launch facility. We launch our own rockets. What we're doing at Mishal Aerospace is game-changing. We're providing an underserved market with access to space. In addition, we will be the first company to access the moon. By doing so, we will allow the scientific community to have access to lunar resources that will improve mankind in developing more research in fusion engines and using alternative sources that are available to the moon. From this research, we will be able to solve energy problems as well as other things that are unknown to us today.
So that video kind of gives you an idea of what the company purpose was and why we started it. A lot of people tell me, okay, how do you make money? Do you sell the rocket? Usually you don't sell the rocket to people. What happens is, let's say you guys have a satellite. You come to me and you're like, hey, Michelle, I have a satellite. I need it to go to low Earth orbit at this inclination. Then you come and bring your satellite to me, and I integrate it into my rocket. I launch it. So how do we make money? We make money because we give you the service of launching your satellite into space with our rockets. And to give you an idea of what, because I keep saying one kilogram all the way to 500 kilograms, which is 1,200 pounds, what that weight is, if you have 1 liter bottle of water, that's 1 kilogram. It weighs 1 kilogram. But 500 kilograms is basically the weight of a grizzly bear. Not the volume of the grizzly bear, but the weight of the grizzly bear. So that's basically how the business makes money. And then people are like, oh, Michelle, well, if you put the satellite in space, and then what? Done. You're done. You put this client and you're over. No. This is the beauty. When you put stuff in low Earth orbit, the life cycle is 2 to 3 years. What does that mean? If you put a satellite today, within 2 to 3 years, you're going to come back to me and be like, hey, I need to replace my satellite because it will not last longer than 2 to 3 years. So you have to replace it. And the other beauty of it is sometimes you're launching as a constellation. What does that mean? It's multiple satellites launched in space so that they can give you maximum coverage depending on where you want to put it. So you could potentially launch 20 satellites if you want, or 100 satellites, depending on your purpose, because these satellites could be used for Earth observation, reconnaissance, scientific payloads, as well as other telecommunication and other things that they could be used for. Just to recap, so the idea was, I don't know if this thing works, but so you have this suborbital vehicle, as I mentioned, it goes into space and comes back down. So technically, you could test your telemetry on this rocket. And this exact rocket is the same one here, the small ones. So I can add and remove boosters as I need, depending on how heavy the payload is. And so this rocket feeds into the development of this rocket, because it's the same rocket motor. And this is a hybrid, and then this is a liquid rocket. And then this guy feeds into this guy. You just add more boosters, and then you can have a lunar vehicle which takes you to the moon. So obviously, when you start any business, it's quite hard. It's not easy. First of all, when I started, when I was 26, people are like, oh, you're crazy. You're 26, what do you know? And I'm like, true, I am crazy. That's one aspect that I know for a fact, is I am crazy. And two, you know what? I'd rather try and fail than not try at all, because then I wouldn't know if I'm going to succeed or not. I wouldn't know. I need to fail or whatever it is, but I have to try. So the idea was, imagine you start this company, and these difficulties I'm going to be talking about, you have financial difficulties and technical difficulties. Both happen simultaneously. It's not like you're lucky that one happens and then you're done with this. No, they happen at the same time. So we started the company. We had funding to start the company. The idea was to continue till the end to commercialization. And I had an investor that was fully vested for the whole project, but then ran into some financial issues midway through our project. So that is not cool. Like I always say, I welcome technical difficulties with open arms, because I can find solutions to the technical difficulties. I can try to find investors, but convincing humans to put money in a high risk and long-term investment is sometimes a little complicated. So at the same time as we were developing these rockets and we were designed our rocket, we were about to start testing the rocket motor in a static test. I discovered that the investor cannot fully fund the whole project. So for 2.5 years, I kept looking for investors as we were developing at the same time. And the unfortunate thing that I found is there are two types. So you can think of all the types of investors: angel investors, high wealth individuals, venture capital, you name it. I've gone to all of them to try to get funding for this business, because this is a business that requires millions of dollars. It's not like a few $100,000. So it's a lot harder to convince people to put that much money. And what I found is either the investors do not understand aerospace, so therefore they shy away from it. They're like, oh, it's a subject that we don't understand, therefore we're not going to put money in. Or they do understand aerospace and they put all their money in SpaceX. And they're like, well, I'm not going to put my money, rocket company, even though you're not a competitor, but you're still a rocket company, which means high risk and long term. So they're like, we're not going to put money. So it was kind of very difficult to find investors. At the same time this is all happening, we ran into some technical difficulties. I'm running out of money, okay? And I have no investors in sight, but I need to achieve no matter what. So I came in with this idea, I'm going to have this gigantic company eventually that has thousands of employees. We're going to go to the moon, bring back samples to Earth. We're going to improve science. We're going to do this. We're going to do that. And now I'm faced with, whoa, I have to shorten like the goals of this company, but I started like, I wanted to do this. Now I have to like downsize my milestones. So it was very frustrating to deal with all that at the same time. But as you're dealing with that, you have to put the emotions aside in order to focus. So my concept was at least I have to achieve the milestone of static testing the rocket motor, because then I have proof that our propulsion system works and functions as it was designed. So while I was dealing with this financial thing, our combustion chamber, which is where the combustion of the rocket happens, experienced some failures. Not once, not twice, but 3 times. It failed 3 times. And the main reason was the material we were using was, even though it tested, we tested it for the loads that it was going to experience. Once we put the system together, it was not working properly, and it was a composite material, so it kept having delamination and leakage, and that's not okay. And the reason why we decided to go directly to the composite is because we wanted to test flight hardware, so that immediately, once this is tested, I know I can fly it. Then I was thinking, when it failed the 3rd time, we already knew that the material we were using needs to be changed because it clearly cannot withstand, because the 3 failures led to the idea, because we changed the design a little bit, to the concept that this material will never work. So we need to switch. We already found a new material, but we didn't have time or money to be able to replace it. So what we did is we were thinking, I was like, wait a second, we're trying to test the propulsion system. Let's focus on testing the propulsion system. I don't need it to fly. I need it to test it right now. So then we switched to what I call the battleship chamber, which is made of metal, and we hydroformed it. We did the hydrostatic test. It succeeded immediately, so I was like, all right, we're running out of money. Let's put this thing together. We put this thing. We ship it off to the Mojave Desert. We get to the Mojave Desert, and you're hoping, like, oh, things go really well. No, nothing ever goes as planned. There's always some hiccup along the way, and you have to be able to work with it. So we get to the test facility in the middle of the desert. We put our rocket. We're ready to go. We turn on the valve. Valve doesn't work. So, and it's already like nighttime, almost sunset. So we couldn't delay the test. But luckily, the day after, there was the facility that we were testing at didn't have anyone. So we were able to take that day. So we went back, got a valve, came back the next morning, put everything together, and we were about to go. Guess what? You think it worked? Nope, did not work. We tried. What we had as an issue is pressurizing the oxidizer tank in order to get the right pressure to initiate combustion. And if without that pressure, you're not going to be able to initiate combustion. We try for like 2.5 hours to try to get that pressure. And then Rick Lohr tells me, so what do you want to do? Because we can't seem to get this pressure. And I looked and I said, listen, I only have 2 options here. Either we do this test or I die. Those are my 2 options. Because the whole point is to get at least this milestone. I went from all this to this, and now you're telling me I can't have this? Not going to happen. So we kept trying, and finally, after trying so hard, we were able to get it. You can see it for yourself.
Countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, commit the countdown.
So you'll be able to see it from 3 cameras, different cameras, so you can see how big
7,
it is.
5, 4, 3, 2, 1.
One last one, I promise.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition.
So as you can see, thank God, it finally worked. And we were able to basically get our propulsion system to work, and it worked as designed. We got the same amount of thrust that we wanted, and the data was looking good, everything was good. It was a bittersweet moment for me, because every time I see this video, I become very emotional, because I know what it took to get there. And then the fact, seeing that and knowing like, oh, it works, but I have no money to continue, and now I have to put the company on hold. It broke my heart, because like I basically live for rockets, and this is like very painful. But some of the achievements that I wanted to highlight is basically hydroproofing the combustion chamber, which we failed 3 times because of the material, but then finally we were able to get it to work. Successfully completing the static test of the hybrid rocket that we designed, which is the booster for the rockets that I showed you. And then we received multiple letters of intent from potential clients that were signed and ready to go as soon as we had a rocket vehicle ready. Just to give you some accomplishments and to show you, like this photo right here, this is basically an isometric view of the actual rocket with the parts. And we manufacture everything in-house. So the rocket motor is manufactured with our own proprietary formulation made in-house. This is like pouring it to cast. So what is the purpose of this presentation, and why am I here, and why are we discussing it? As I started earlier, I said it's better to try and fail than not to try at all. So what I learned from my experience is that I am definitely capable of achieving a technology in rockets. Maybe I was unable to find investors, but that hopefully will come someday soon. But at least I tried. I failed from a financial perspective to get investors, where I succeeded technically, which to me is a win-win situation. Sometimes this is one of the hardest ones for a lot of us to accept. You start something and it just may not be the right time for it right now. Doesn't mean you should give up on it. It just means that maybe later on the market will be ready. Like when I started the company, we were the only rocket company targeting small satellites. Today, there's almost over 26 companies that are targeting small satellites. And then most importantly, which sounds like a cliche, but you must focus on the dream no matter what the obstacles are. I have faced so many technical problems, financial issues, whatever it is, and I managed to somehow not let this depression kill me from like not trying. And I kept pushing no matter what, and hopefully I will continue to do that for the rest of my life. And one of the most important things, like if I leave you with nothing at all today, failure is the seed from which success grows. And this is important because a lot of us today feel like, oh, I don't want to fail, I'm scared to fail. I think fail. The more you fail, the closer you are to where you need to get. And the more you fail, you recognize how not to do things. And therefore, you will succeed eventually. So don't be afraid to fail. Take that risk, especially on yourself, and achieve what you want to do. And, well, that was the last one, is don't be afraid to fail. And that's it. Thank you so much.